Today in our today's session, we'll be looking into more examples regarding IO mapped IO and memory mapped IO. So we'll be looking into PCI. We'll not be going deeper into PCI, but we'll be looking into topics related to memory mapped IO and IO mapped IO, which are used in PCI, and we'll be looking into smbios. SMBIOS, it stands for System Management BIOS. It is a standard which is developed by DMTF. DMTF stands for Distributed Management Task Force. The purpose of this standard is to allow the operating system to retrieve the information about the PC. So you can read this thing. It says the specification addresses how motherboard and system vendors present management information about their products in a standard format by extending the BIOS interface on an Intel architecture systems. So it is a standard. It is a standard which is developed by DMTF, which allows motherboard and system vendors to provide information about their products. So information can include the make, the model, the serial number, the BIOS version, the processor, the memory configuration, etc. So if you want to read more about this standard, you can download this document and you can read more about this standard. So this is smbios. So on board, what happens is smbios will put a smbios entry point table somewhere in memory. So this table is located in between the addresses F440s to F4Fs, and it must be present on a 16-byte boundary. So if I want to find out this smbios entry point table, I need to search a region of memory which is starting with string underscore sm underscore. So I want to find out the string where the string is present underscore sm underscore in this range. There is that is the place where the smbios entry point table is present. So I wrote a sample user program. So in this program, I have opened dev.mem in read and write mode. Then I'm memory mapping this. Starting length is starting address is this of this much of length. So once I memory mapped it, I call a function find smbios entry, which will look for the string sm underscore sm underscore. So this is now searching for. So it is as it says, as we have seen, it is on a 16-byte boundary. We are searching every 16 byte. We are looking for underscore sm underscore. Once we find it out, we are printing the address of smbios here. Finally, after we find out, we do memory unmap and then we close the file. So when I run this, it needs sudo user, sudo permission. So we have to run it as sudo user. We have found it is present at F69C0. So the other way how I can find out this is, I can also do sudo cat, or I can do an hex dump dev mem, and I can grep for underscore sm underscore. And you can see it is there, underscore sm is there at FC960. This is what we have found out. This is what we have found out using our user space program. So we have now found out the smbios table. So smbios will put a table somewhere in memory in between F40s to F4Fs, and this table is smbios entry point table. And this table, to find out this table, you have to search for this particular string, which will start on a 16-byte boundary, which is what we have able to do it. So this is the structure which is present on this is the smbios table. So this is the structure which is present at that location. First is the entry point string, which is underscore sm underscore. Then we have checksum. Then we have length. Then we have major version of smbios, minor version of smbios. One more important is then we will have length of the table, which is containing all the structures. So, and the address of the table where this is present on the memory. So table address contains address of the table that contains all the structures with information about the PC. All the structures are located from table address to table address plus length. So these two fields are very important. So at the smbios entry point table, you have a address of the actual structures. So table address contains the all address of the table containing all the structures which has the information about the PC. So these structures are located adjacent to each other in memory with a new structure beginning as soon as the other one ends. And they follow a particular header. So each structure is having a header. So this is the header. And then it will have a specific table. And finally, it will have a string table. So again, in the header, you have a field known as type, which will indicate the element, what element the structure contains about. So we'll not be going in deep, but just for, so we have the different types. The value of type is 0. This means it is BIOS information. The value of type is 1. This means it is system information. The value of 2 is header type is 2. This means it's mainboard information. So I wrote a sample user program again, and this is just printing the, so this is still the same. The code is same. Find smbios entry is same. And once we get the starting location, which is by finding the string underscore sm underscore, I'm just printing the table address. So I'm typecasting it to structure smbios. So this is smbios table structure, and then I'm printing the smbios address, which is the table address. So the table is present at location E0010. So table is present at location E0010 here. So we can go to that location, and we can suppose if I want to see that thing, I can say hex term cdef name, and I can then look for, I can see, so man hex dump can skip offset from the beginning of input. So S skip offset from the beginning of input. So let's skip hex dump hyphen C small s, let's say E0000 and def mem, and I say less. So it started from E00. Instead of starting it from all zeros, it started from E40. Now you can see, as I said, our table is starting at E0010. And you can see a lot of information like phonics technologies and CPU information. A lot of strings you can see. As I said, the structure from this, there will be a header, there will be a table, and then there will be a string table. So these are all string table, and you can read more about this smbios, which we are not covering in deep, but just the basics of smbios. You can see a lot of strings are present in this structure. Or I can just say, I can give a length. Man hex dump will say, for length, it is hyphen n. So let's give a length of 1000. So it's not printing that. Or say, once I say 10, so only give 10. Say 1000. Oh, it's not accepting hexadecimal. So it's accepting only decimal. So now I can say strings. Or strings, it does not work like this when it with hexadecimal. You need to use cat with strings. So there's a tool which you can use. So DMI decode. So this is a tool which is provided by Linux. DMI decode, it is a tool for dumping a computer SMBIOS table contains in a human readable format. So DMID code is a tool for dumping smbios table in a human readable format. So instead of doing hexdump on devmem, you can run DMID code. So when you run DMID code, it will try to locate the DMI table or smbios table. It will first try to read the table from sysfs. If failed, it will try to read this table directly from devmem. So if DMI decode succeeds in locating a valid DMI table, either from sysfs or from devmem, it will parse this table and display it. So let's run DMI decode as a non-root user. DMI decode. So you can see it is trying to first look into sysfs. As we are running as a non-root user, it's failed with permission denied. So assess firmware DMI tables smbios entry point. Let's do an hex dump on this. So as this is failed, it is now trying to look for devmem, and as devmem, as we do not have permissions, as we are running DMID code as a non-root user, it is also failed with permission denied. So let's run this. Let's see what are the contents which are present in this file. So you can see it has underscore sm, and then it also has the address which is we are looking for, which is E00010. This is what is the table address. So entry point is present in this sysfs. If it failed to read from sysfs, then it will manually search for underscore sm underscore in devmem. So now let's run it in a normally on the root user. So you can see it has given a lot of information. DMID code. So BIOS information. So as I said, type 0. So type will identify different kind of information. So type 0 is for BIOS information. It is also saying getting the SMBIOS data from sysfs. The version of SMBIOS is 2.7. There are 620 structures. As we said, SMBIOS is collection of structures. And the table is present at this address. So this is from the data from the SMBIOS entry point table. And then we have each and every structure information. So we have the BIOS vendor is Phonics Technologies. The version is 6, the release date. So you can get the BIOS information directly using DMID code. And other information is also present. Then it is showing the system information. Who is the manufacturer? So this is the DMI type 1 of the structure header type. From the header you can get type, and type 1 is for system information. You have the VMware is a manufacturer, the product name. So you also have the serial number. So a lot of information. Then you have board information. Who is the manufacturer for the board? Intel Corporation. Chassis information, processor information. How many for each and every CPU you have the processor information. You can see CPU 1, CPU 2, CPU 3, CPU 4, CPU 5. So all the CPUs which are present on my system, you have those information. So even if I have only few CPUs, you can see it's giving information of more than those CPUs. I have only like 8 CPUs. It gives me more information. Nearly a lot of CPU information is being given. So nearly 128 CPUs information is being given by this. And then we have memory controller, memory module information about RAM, cache information, etc. So a lot of information is given by SMBIOS. So if you want only a specific information, then you can use -s option. So DMID code -s BIOS version will only give that particular information. So BIOS version is 6. If I only want to find out the BIOS vendor, then I can directly search for a particular string like BIOS vendor. So using S, you can search for a particular string. system manufacturer, who is my system manufacturer. So this all information is present from the smbios table, which is present in the dev memory. System serial number, if I want to find out the serial number of my device, this is my serial number. So by default, as we said, DMA decode will first try to use sysfs, and if it is failed to read from sysfs, then it will try to read from devmem. You can also instruct DMA decode to not to read from sysfs, instead to read from devmem by saying DMA decode hyphen hyphen no sysfs. In this case, it will read from devmem. So it says scanning devmem for entry point. So it is not, now it is not using sysfs, it is using devmem. So if I do not add this no sysfs, it will use sysfs. So we have seen a tool DMA decode, which will print the smbios structure information in a human readable format. So there's one more tool, BIOS decode. So this BIOS decode is more than a DMA decode. It has more information than DMA decode. It prints the DMI or SMBIOS information, and it also prints additional information like ACPI, plug and play, sysid, BIOS32, etc. So just let's see what is this BIOS decode. So it parses the BIOS memory and prints information about all structures it knows. So this all will print, and it again reads the devmem for that. Devmem is a file which it reads for printing that information. So let's run BIOS decode. So see, as I'm running as a non-root user, it was trying to open devmem and permission denied. Let's run in a sudo user. So you can see a lot of information is being printed. SMBIOS structure is present at this location. Then we have BIOS 32. Then we have about ACPI and other information. So this is all about smbios. We have seen smbios. It's present in devmem. We have seen tools like BIOS decode and DMI decode, which are used to present that information in a human readable format.